Good morning, learners. Welcome to our today's maths lesson. As I promised you, this week we'll be dealing with percentages. It's a new topic, percentages. And our first subtopic is going to be conversion of fractions into percentages. But before then, I want us to understand what percentages mean. Now, in simple terms, a percentage is a special type of a fraction. A special type of a fraction. Why am I saying that it's a special type of a fraction? We know fractions have what we call the numerator, and we also know that fractions have denominator. So these two parts guide us to be able to understand what fractions are. Now in this case, if I write 2 over 5, this is a fraction. 2 over 5 is a fraction with numerator 2 and denominator 5. So that is a fraction 2 over 5 with numerator 2 and denominator 5. Now if you look at what we call percentages, you realize that the lower number, which is the denominator, is always 100. Meaning that that's a special type of a fraction, because we cannot be able to write anything else at the denominator. We can't write 1, we can't write 2, we can't write 5, we can't write 20, we can't write 99. We can only write 100. I want to give you an example of a percentage. Like, you can have 2%. 2% is going to be written as 2 over 100. This is simply 2%. I want you to look at this one. So, we're going to have any number, say y over 100. So this is going to be the version in which we are going to write our percentage. Any number from 1 to 99 or even 100 or even 130, whatever it is, but it's supposed to be out of 100. So this is what we call a percentage. I have a table here. I want us to look at this table to be able to understand further what a percentage is. If you count my squares, in this case, you realize that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on that side, they are 10. And if you count downwards, you're going to realize that the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are also 10. So, in short, we can be able to count the total number of fractions in squares or cubes in this particular bigger square. So for us to be able to count, you can count physically, but also you can be able to count looking at the length and the width, because it's a square. So you're going to realize that the squares are going to be 10 times 10. That is going to give you 100 square units. 100 square units. 100 square small squares. So if you want to realize the number of squares that are shaded, the shaded squares are going to be, we are going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 squares are shaded. Out of how many squares? Out of 100 squares. So in short, you can say, also we can have the unshaded squares. The unshaded squares, if 10 are shaded and the total squares are 100, meaning that if you take 100 minus 10, you will get 90. So 90 are not shaded, and so you say 90 out of 100. Someone will come and ask you, what is a fraction, or rather what is the percentage of the shaded squares? So if you want to get the percentage of what is shaded, you simply say it is 10 out of 100. 10 out of 100 squares. So 10 out of 100, but if you want to convert, this is a fraction, remember this is a fraction. if you want to convert this fraction into a percentage, you simply multiply by 100%. So if you want to understand the shaded squares, you're going to realize that this and this will cancel, as I showed you, 10%. So 10% is shaded fraction, the shaded fraction. If someone asks you, what fraction is unshaded? You simply get 90 out of 100, because all of the squares are 100. Then you multiply that by 100%. 100%. And that will give you 90% unshaded squares. Unshaded squares. If you want to understand whether the total squares are out of 100%, you simply add this. What is 0 plus 0? 0. But this is a percentage. 1 plus 1 is 10. You will realize that if you take the sum of the shaded part and the unshaded part, if you add them together, you are going to get 100%. So this percentage plus this one will give you 100%. So each square here is out of 100. So 1 of 100 can also be written as 1%, because the total squares are 100. So let us go back to our topic today and see how we can be able to convert fractions into percentages. I want to give you examples of fractions that we are going to convert. Like for example, you can be given convert 17 out of 100 as a percentage. Then I've already showed you what you're supposed to do. So in this case, you say 17 out of 100 times 100%. And that mark percent is very, very important, means out of 100. So the percentage mark looks like this. A 0, a slash, another 0. Sometimes you can mix them like that, and you can also write like this. So this will give you 100 and this will cancel, 17%. So 17 out of 100 converted to a percentage will give you 17%. And let us to look at another one. Express 3 over 8 as a percentage. That means 3 over 8 times 100%. That percentage sign is very, very important. So we start simplifying. Remember I showed you how to simplify. Either you can simplify diagonally or you can simplify vertically. That one is accepted. So divide by 2. 8 divided by 2 you get 4. 100 divided by 2 you get 50. 4 divided by 2 you get 2. 50 divided by 2 you get 25. In this case, you realize that there is no common divisor between 3, 2, and 25. So this what you do is multiply 3 times 25, and that will give you 75 over 2. When it reaches the learner, you can be able to simplify further, because we have a smaller numerator and a bigger, a smaller denominator and a bigger numerator. So you simplify. 2 gets into 7 3 times, you get 6. You make with 1, you drop your 5. 7 times, 2 times 7 is 14. You remain with 1. And so your case here will be, what you have gotten here, that 7, as a whole number, the remainder, which is 1, over these 2. And then don't forget the percentage sign. So 3 over 8 converted to percentage simply gives you the 7.5%. Or you can also say that 7.5%. Half is always 0.5. A quarter is 0.25. And 3/4 is 0.375. So you can move on and complete other few questions. Sometimes you can be told half. You can begin half. Then you are given 100. And you ask what number will be represented, will be put there to make that question very correct. Now I understand we did equivalent fractions in class 5, and I told you that for you to be able to understand what number you put here, There are two ways of doing that. You assume this question mark is maybe a y. So you multiply like that. So 2 times y is 2y, simply 2y is equals to, then 100 times 100. So divide by 2 to get the value of y. So our y is equals to 50. So in this case, here is 50. So how is that possible? That here we have 100, and then here you have a question mark. You ask yourself, what number has been multiplied by 2 to get 100? That number is 50. So you multiply 2 times 50, you get 100. So whatever you do here, you also do here. So 1 times 50, you still get 50. So there are two ways of doing that. You ask yourself the question, what number has been multiplied by 2 to get 100? Because we always want the denominator to be 100. Let's do another one, Lana. You can be given a question like 17 over 25. You are told to express the denominator to be 100. So here you say, this is 100. If you are told to express the denominator to be 100, you simply write 100 there. And then the question will be, you can put x there. So 25 times x is going to be 25x is equals to 17 times 100, which is 1,700 over 25 over 25. So in that case, Lana, by 5, 3 for 15, 20 for 0, 340. By 5, 1, by 5, 6 for 30, 8. So in this case, you are going to realize that our x is going to be 68. Like I want us to look at this question properly. What number is multiplied by 25 to get 100? That number is 4. 25 times 4 is 100. If you multiply 17 by 4, Lana, you are going to get 68. Because 17 times 2 is 34, plus another 34, you get 68. So there are two ways of doing it. You ask yourself the question, what number is multiplied by this number to give you 100? Because you want the denominator to have 100 as the denominator. So maybe I do the last one. Express the following fractions as percentages. Express the following fractions as percentages. Express the following fractions as percentages. 9 over 15. Let's express 9 over 15 as a percentage, meaning that you simply multiply this by 100%. So by 5, 3, by 5, 2, 0. So by 3, 1, by 3, 3. So 3 times 20 is going to give you 60%. If you want to do it the other way, 9 over 15, then you put this as 100, Lana. And this is x or y, whatever answer you want to pick. So 15x is equals to 900 over 15 over 15. So in this case, your x is going to be by 15, 1, by 15, 6, 0. So this is going to be 60. So our value of x is going to be 60. So your fractions is going to be 60 or 100, which is simply 60%. 60 or 100, simply 60%. So you're going to multiply it like this and get your answer as a percentage. So whenever you do it like this, what you get here is your answer and write it as a percentage. So you write 60%. Don't write 60 or 100. In that case, you have been told to express as a percentage. Unless, number 2, where you're told, express the following with 100 as the denominator. So you're going to leave always the denominator as 100. And so you are going to have an answer like this. That is only number 2 alone. So I have done what I wanted to do in this lesson. And now I know you're asking yourself, where do we apply these percentages? Sometimes maybe you're a shopkeeper. A shopkeeper can sell things in terms of percentages. Like for example, if the person bought 20 loaves of bread, and maybe five breads went bad, and then he or she sold the rest. So what percentage did he sell? He sold the percentage 20 minus 5, he sold 15 breads. So 15 breads out of the total. How many breads were there? 20 times 100%. So in this case, this person sold a percentage, 75%. So this person sold 75% of the total breads that he or she had. He had 20 loaves of bread, 5 went back, so he sold 15. So 15 out of 20, if you want to convert that into a percentage, because you want to know the percentage of the breads that he or she sold, 15 out of 20 times 100%, and you realize that he only sold 75% of the total breads that he or she had bought. So I want to leave you with some questions here. Exercise 62 and 63. Exercise 62 and exercise 63. I want you to do everything that is going to be found on page 84 and 85. 84 and 85. So ensure that you do everything right, following the correct formula, and I'm sure you're going to realize that percentages are very, very easy to handle. So until next time, I want to wish you well. Ensure that you do the work and forward for marking. God bless.